Welcome back everyone. In this video I try and make some repairs to our walkie-talkie batteries, as well as check out some rechargeable AA's, AAA's and 9 volts that were sent to us by a viewer. So in our last video we showed you some of the highlights of our time in northeastern Colombia. We were traveling with some cohort friends. Thankfully they were there to pull us out of a hole, and then we pulled them up the mountainside. And then my fuel accelerator pedal stopped working in the middle of an uphill freeway. That's the times you wish you had some radios, the walkie-talkies or something, to give the news to your friends. And when you need to back your big truck up a narrow windy road like this for 200 meters, that's another really great time when you're glad you have a spotter with a radio. But the keen eyes among you will have noticed that we weren't using our radios. Instead, we were stopping our trucks and running back and forth to tell each other short messages. And that's because both of the radios were stone dead. I couldn't even recharge them. So let me show you why and how I'm going to fix it. So these are our Bofeng radio walkie-talkies. Half the overlanders we meet on the road have these, and the other half have some El Cheapo Costco 4-pack family radio service walkie-talkies. And these will transmit on those frequencies as well, so we can still communicate with them. Just when you're using two of these, that's a lot clearer, and they're higher power, and with these antennas you get much better range. Additionally, these have access to far greater spectrum of radio frequencies, and so you can dial in whichever frequency you want and get away from the interference that everyone else is using on those family radio bands. Anyway, this isn't about the radios themselves, it's about the batteries. As I said, both radios' batteries were stone dead, and I couldn't charge them. The first reason was the 10-volt wall adapter that came with the set. It died some years back. No problem. I just used my digital power supply to generate the 10 volts that the little base station wants, and that's how I've been charging it for the last few years. But then a few months ago, the base station itself gave up the ghost, and so I couldn't charge batteries anymore. I did crack open the base, and as you can see inside here, there is a HXNWS constant voltage, constant current charge controller. So it's not just a pass-through that passes the voltage into the battery, and then the logic is handled in the battery. But that's no problem. I've charged them a few times with the iMax B6 Mini. This is a super versatile little charger. I've used it many times to resurrect all kinds of things where the battery management circuit or the battery protection circuit in the device has triggered low voltage because one of the cells is too low, and so then I can connect it to just that one cell and charge it up, or charge all of the cells individually, get it all happy again, and then the BMS handles it properly from then on in. So I have used this to charge the batteries for the last 2 or 3 times that I needed to charge it. That works great, of course. But the last time I went to charge it, this one battery has swollen up really bad. Worse than a Samsung S9. But because you shouldn't charge a swollen battery like that, I just put them both into storage and figured I'd get to it eventually, and that's why we had no batteries for the walkie-talkies when we needed it the most. So I figure I should get these going again so that next time I'm in such a pickle, I have some radios. The first thing that came to mind was I do have this battery Eliminator unit here. This plugs into the back of the radio, and then this plugs into the cigarette lighter to power it from your vehicle's 12-volt outlet. Unfortunately, I plugged it in and nothing happened. And so yesterday I peeled it open and the wire wasn't even soldered to the circuit board. So of course that's an easy fix. I just soldered it back on and tried it out again. Unfortunately, it powers up the radio, but as soon as I go to transmit, it reboots the radio. This circuit in here doesn't have enough current to transmit when I press the transmit button. And so It's garbage. All right, let's get to fixing. The easiest thing I'm going to do is the first thing is I'm going to gut this circuit out of this battery eliminator and replace that with the LM2596. This is a buck converter. It takes a high voltage and reduces it to a lower voltage, which you can set by turning this trim pot. So let's tear into that. So I've unsoldered the contacts from the output. Unfortunately, when I was in here repairing it, I thought it would work, and so I went and glued all this down so that it would not come loose again. Might end up just cutting her off here. Garbage. So like I said, I'm going to use this LM2596 DC to DC converter board. They're really simple to use. As you can see on the back here, in positive and negative, and then out positive and negative with an arrow so you can't forget. If you're new to soldering, there's nothing that should be that scary about it. I highly recommend, if you don't have one and you're just doing small hobby type sized stuff like this, the Miniware TS100. It'll run on 12 volts up to 24, 25 volts. It's got this beautiful little display, and there's alternative firmware called Iron OS that makes some additional features available, like motion activated auto turn off and so on. But all I need to do here is pre-tin these connections, pre-tin the wire. These are pretty little wires, but running what I brought. And then in positive, in negative. And here you can see I've connected the wires from the output to the terminals. A little bit of crisscross action there. And then in OEM style, I'm just going to put a big gob of hot glue underneath here and slam her down. Also loop the input wires here, and I'll put some hot glue all over that just to strain relief it. Alright, there's the hot glue kind of hardened up a bit. I don't have a cigarette lighter plug in the back here, but I'll just use these jumper cables straight from our lithium battery fuse block. 13 volts going in here. Why is it not lighting up? Tell me. Only half of this cigarette lighter ground is ground. So now we need to confirm that we're getting 12 volts in, or 13, doesn't matter, 13.3, and maybe can barely see it here. Tiny little green LED, barely glowing, and the output I've already set to 8.5. 8.6 will be fine. Here we go.
Panel mode.
I couldn't lie to you, Sheriff. You're too good a man. Over. Alright, one down. Let's move on to... Oh, there's my lunch. We had celery and hummus for lunch. Let's move on now to the swollen battery. What do you know? It doesn't work. As you can see, it's swollen up pretty good. So, this case was glued shut pretty good, so I spent a few minutes chipping away at it with some tiny pliers and nippers, and I've got the battery out of here, and you can clearly see these lithium-ion cells are swollen up. Here on the bottom is the BMS to each of the cells, and that cuts the power to the radio when the batteries get too low. So my gut reaction is to take this out and then use the case to hold two 18650 cells. I have a few of these along with me, still left over from my laptop battery recycling days. And I use those for all sorts of camera gear and general battery hackery. Unfortunately, this case is just a bit too thin and they don't fit in here. It's not going to close. So, of course, I 3D printed myself a new case. And that does fit. I actually printed two of these, but I'm only going to make one right now. I went to my junk drawer of random bits and bobs salvaged from wherever and found a small piece of copper plate, and I'm going to use that to make the contacts here in the top. And the rest is pretty simple. I just need to take this BMS board off of these swollen cells and connect it in the same polarity to the new 18650s. And I've also found some little scraps of thin wire, but it will suffice for these low current demands. Just going to detarnish the copper a little bit. I'll cut a section to length here. I'm just using the soldering iron tip here to warm the copper just enough to warm the plastic just enough to let this slide into that little slot, which is a bit tight on these prints. So I'm just making note of all the contact positions. Absolute positive and negative are these two. This will be 3 volts. And this will be 3 volts. And these two are the outputs, positive and negative. And with the pinout of this BMS noted, I can remove the old cells. I just used some blue tack there to hold the batteries down in place, and then I've installed the BMS from the original battery pack using the exact same cell polarities, and now this can drop in there. So that's about how that's going to sit, but I'm going to lock this all in place with some hot glue just to keep it from moving around on me. And then a dollop behind the BMS here, just to keep it in place. Freshen up the solder. Tin the ends. Negative to negative. Positive to positive. Alright, so this had me stumped for a little bit. I got it finished, put it together, and it didn't work. Couldn't quite figure out why. Turns out these contacts in here were just a little bit too low, so I've put a ball of solder on the top there. And then I've tucked this piece of cellophane packaging material over the top of the cells just to kind of protect that BMS from touching the metal plate in the back here.
Channel mode.
Breaker 19, what's your 20? Go find your mom. Come on back. Over. Next, let's talk about annoying things that use AA batteries. As fairly techie nomads, we have lots of equipment and other stuff that uses AA's, AAA's, and 9-volt batteries. Things like our binoculars, my voltmeters, infrared temperature gun, my favorite cordless mouse, and this wireless keyboard that we use to trigger lights and scripts in the truck. Plus other stuff like this microphone, or this audio recorder, these headphones, this coffee zhuzher, this camera flash, this 3D controller, And of course, some of these things can now be purchased with rechargeable batteries built right into them. These headphones, for example, there's a newer model that's rechargeable, but these still work great for my purposes, and I don't need the expense of new ones just to have a rechargeable battery. So I started looking online for some rechargeable AA's and AAA's that don't suck, like nickel metal. And of course, Amazon is full of these USB rechargeable lithium batteries, but they're getting mixed reviews, especially among the no-name brands. And it's a moot point because Amazon won't ship batteries by air freight or air to Colombia or Ecuador. But not a week later, out of the blue, one of our viewers named Tom from Salt Lake City sent me an email and asked me if I could use such batteries. And of course I said yes, very yes. But as with most things, I told him you probably can't ship them to Colombia. And he said, hold my Red Bull. Not even a week later, I'd received a care package with some AA, AAA, and 9-volt lithium batteries to check out. So PaleBlue has designed these batteries in traditional formats, double, AAA, etc. And included inside each cell is a lithium-ion battery, a USB-C charger, and a BMS that monitors the battery voltage and steps it down from the 4-volt lithium down to 1.5 volts alkaline, what the alkaline devices are expecting. So, full disclosure, Tom sent these to me for free, but this is not sponsored. I've not been paid to say anything. There will be no affiliate links in the description down below. Everything I'm saying is my own honest opinion. So let's tear into these and check them out. So here they are. AA, AAA, and the 9 volts. They all come in the fairly nice packaging. A reusable travel case that's nice and hard, nice and rigid. The batteries themselves, of course, and then it includes the USB-C breakout to charge them all up. Really nice silicone jacketed cable. You can hear that? Kind of metallic, high quality sounding connectors. And they just plug in like this. The package says charge before use, so let's do that. I imagine AAA's are going to be much the same. Yep. USB-C there again. And the 9 volts. Come here, you. There we go. Looks like these are micro USB. Little slidey door over the charge port. So there they are. Now the packaging says right on it, not even in the manual, but right on the sleeve here, charge before use. So we'll get that done. So the first thing that came to my mind when even considering such a battery is because they've shoehorned this USB-C connector and a charging circuit and a BMS all inside this cell, how much room is left for the battery itself? How much capacity would such a battery have? And how would that stack up to a traditional alkaline battery? Fortunately, that's really easy to quantify. I'm going to use our trusty iMax B6 Mini and this AA battery holder socket that I 3D printed. And I've got this set to a discharge cycle where it will put a 500 milliamp load on the battery until it reaches 0.9 volts. So I actually ran down to the corner store, a little tienda, and bought 2 brand new Energizer Max AA batteries. They sell them as singles out of a large retail package, but you'll have to take my word for it that they're new. And let's set it up here and run a discharge on it. So, as you can see, the Energizer ran for 3 hours and 10 minutes, and we got 1,597 milliamp hours out of it before the battery voltage dropped to 0.9 volts. So, now let's compare that to a PaleBlue AA. And the PaleBlue rechargeable lithium battery ran for 3 hours 27 minutes, and we got 1,738 milliamp hours out of it before it cut out. And did you notice anything in that time lapse? The alkaline battery voltage slowly drops and gets lower and lower as the battery is depleted. This is why a flashlight gets dimmer and dimmer as you deplete the batteries and get closer to dead. But because the PaleBlue battery is taking a higher voltage from a lithium battery and converting it using a DC to DC converter to create the 1.5 volts, it stays locked at about 1.5 volts for the whole discharge. I say the whole discharge, but I did notice a very clever little trick these things are doing right at the end of the discharge cycle. Maybe you noticed it too. To understand the magic these things are pulling, you first have to understand how a traditional BMS works. So I'll use this radio BMS that we just did as an example. It's wired in between the batteries and the output contacts on the battery here, and it's intercepting the battery voltage, and it monitors the voltage of each of the cells, and when the battery voltage gets too low, it kills the output to the contacts on the outside of the battery case. The problem with that is, in the context of a device like this audio recorder that's expecting a traditional alkaline AA battery, is that the onboard voltage detection and low battery warning would never trigger. It sees 1.5 volts the whole time, recording its file, happy as a clam, and then suddenly it would just cut the power and you'd lose your last file because the device couldn't write the end of the file and it would be corrupt. And to be honest, I was kind of expecting that to happen with these. But as I was watching these time-lapse videos on the computer, I noticed that as the battery was approaching the end of the cycle, the output voltage drops to 1.1 volts or so and continues that way for a while. So this clever trick allows the batteries to trigger the low battery mechanisms in your devices, and you get a low battery warning rather than just getting cut off. So in the course of filming this video, I've charged and discharged these 4 AA's extensively, discharging using the discharge cycle on the iMax B6, and 1700 milliamp hours approximately every time. They continue to work great, and I've used these AA's and AAA's and the 9 volts tested in all of the appliances I have, and no surprise, it's 1.5 volts. They work perfectly. So yes, 10 out of 10, I would recommend. If something changes, I'll throw a card up here with the update. Big shout out to our supporting channel members. It's your support that lets me make videos like this, stuff that I want to do, videos I want to make, and not force feed you guys affiliate links to garbage products that I don't actually believe in. Thank you very much. That being said, there will be a link to PaleBlue Earth's website in the description. It is not an affiliate link. Just a gesture of appreciation. I do really like these batteries. I appreciate Tom sending these to me. So if you guys are in the market for some lithium AA rechargeables, check that out. I'll also put a link to the Jungle website there. Also not an affiliate link. And yeah, that's going to be it for this one. Thanks so much for watching. We'll see you next time.